Hello folks, welcome back to the Model 3 PCB project. Not the video I wanted to be making for you today, so in order to maximize views and thus my embarrassment within the engineering community, I'll have to do one of these kind of clicky thumbnail kind of things where I go, or so try those out and tell me which of them you think would be best, because I have screwed up. I've screwed up pretty royally to the point that this inverter here is, or this board here is not going to work any further than where we currently were, because my plan for this week and my hope had been to show you some wheel spinning in the third under throttle control. That ain't gonna happen. Let's have a look at why. So before us on the bench, we've our inverter equipped with our V1 PCB, and this is what I had over in the V50. And yesterday afternoon, evening, I was trying to tune the FOC settings, and I found that I really could not get it to run reliably at all. It was extremely erratic behavior to the point that it actually ripped one of the brake pads out of the third's front caliper, but you know, that's not what we're looking for. So I just got the inverter here, 12 volts power applied, and we're connected over the web interface. So I'm going to just kick it into manual run mode here, and we're going to observe something. So we're now in manual run mode. I can hear our power stage oscillating. And if we go into dashboard, that should go to run, which it does. Now we got errors because there's no resolver plugged in, but that's not what we're here for. So if we go to our plot and gauge to add, I want to add IL1 current sensor and hit start plot. You're going to start seeing this thing looking like my heart rate when I realized what the problem was. That's bad, okay? That's bad. We have got a jitter on the current sensors of anything from about 12 to 15 amps. So obviously there's no current flowing here, there's no high voltage, there's no motor connected. We should be seeing a little jitter on that, but certainly not that amount of noise on our current sensors. So, Damien, you've obviously screwed up, I hear you say. But wait until you find out what the wait till you find out where I've screwed up on, because yeah. So let's put a stop to that, and let's do some oscilloscope probing, shall we? So this is us probing on the IL1 current sensor. This is the output of the filter before it goes off to the microcontroller and the, what's the name of it, overcurrent protection circuit. And that's bad. We've got anything up to over 600 millivolts of ripple on that. So the old ADC in the STM32 would be not exactly pleased with that. So, where is this noise coming from, I hear you say? Aha! Yes, internet, I hear you. Let's probe the supply line, you say, to the current sensor and see if it's coming in that way. Good idea, internet. Oh yeah, there's our 5 volt power supply. And you can even see the little larger, lower frequency chunks in the middle there, courtesy of our Wi-Fi module. Well, problem solved, I hear you all say. It's your high quality XL1509 power supply chip. Yeah, I was thinking the same thing. So I removed them and rigged up my bench power supplies to provide all the discrete rails. guess what? Noise is still there, but it gets better. Let's have a look at the filter capacitor at the analog VDD, or as they like to say, VDDA, on our microcontroller. Come on, C43, where are you? There I am. Whee! Whee! Goes the analog power supply over 700 millivolts of ripple on a 3V3 supply. That's fine, isn't it? Sure, that's great if you don't want to run field orientated control on your inverter. That's perfectly fine. But I got a better one for you folks. So obviously I haven't been sitting idly by. So if the noise wasn't coming from either of my 3V3 or 5 volt switching regulators, what's the only other switching regulator on the board that we have? Oh yeah, that's right. The gate driver power supply. Good thinking, Batman. So let's probe. Let's probe between ground on the... one sec. So we are now going to probe between ground on the main connector, so where you'd be connecting your 12 volt ground on your board, and ground, about 200 millimeters away, on the ground plane over by the gate driver power supply. Oh dear. Oh dear, what's that? We've almost a volt. What is going on, Batman? Well, what we have there, folks, is a failure of yours truly here to properly engineer the PCB. So, Tesla board, V1 open inverter board. So, first thing that I did do, which was correct, was I made the ground plane go all the way around here, around this way, and around the top, which is where Elon does it. So, let's make this a little bit easier and draw it on here with a permanent marker for you. So, our ground plane goes something like that, all the way up around there. So that's the main 12 volt ground plane, okay? Pretty much the same as on the Model 3 OEM board. However, the Model 3 OEM board does something important. It puts this bolt hole and this bolt hole, which are, look there, right up by the power supply, and this bolt hole, and this bolt hole down by the flag, very important flag. Those guys connect to the ground plane, and they don't just connect to it, they're in fact, the holes are in fact via stitched into it too. Interesting. But none of the other holes, like these ones down here on the bottom or these ones on the side, connect to the ground plane. So then I thought, okay, well that's kind of telling. So I got my cheap and nasty handheld inductance meter, and I measured the inductance from ground pin here all the way over to our gate driver power supply, and we get an inductance of about 5 microhenries. Now, it's an uncalibrated cheap ass meter, so let's just use it as indication AB. Okay, so there's 5 widgy wadgies of inductance then between here and here. Do it on a unmounted Tesla board and we get 3 widgy wadgies of inductance. But there's more. Oh, yeah, there would be if I could work a camera properly. Do the same test on a Tesla board mounted in the inverter, and you get 1 widgy wadgy of inductance. And guess what? This one doesn't ground bounce. Oh wait, maybe I can do the sad face like this now. Whoa. Right, sad face done. You have to tell me which of those will be best for the old clickbait thumbnail. Oh, really? You'd have to tell me which one of those will be best for the clickbait thumbnail, folks. So that's it. The V1 board is toast. My hopes of spinning the Tard's wheels this week to garner more love and appreciation from my vast audience is now down the toilet. We did know that we were going to have to go with a V2 anyway, so this has just accelerated the process. Pity we weren't accelerating the Tard, but there you have it. So there were, you know, layout problems, like the connector needs to move a couple millimeters, and some of the mounting holes need a bit of movement, and we had component values, a little bit of a tracking problem, blah, 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 blah. No one cares about any of that. Probably no one cares about any of this anyway, but it'll make me feel better to tell you folks, because a problem shared is a problem halved. So I hope you've not enjoyed this as much as I have absolutely hated making it for you. So I guess what we're going to have to do is, on the V2, put some via stitched holes here, and here, connecting to ground plane and going to the inverter case. And also try to beef up that plane as much as I can, maybe with some more via stitching around here. Ooh, via stitching. And then I'll just have to cross my fingers and donate another like 600 euros to JLC PCB and see what I've screwed up then. So until the V2 time, folks, don't forget to check those links in the description where you can donate money so I can waste it for you on stupid projects like this, where I make amateur hour mistakes with your money. Give it a break. But you can check the links for the Open Inverter Forum and GitHub, where you can laugh at my ridiculous designs. And other people's channels are linked in there as well. They're more fun than this one. This one's bad. So, yeah. Until then, happy via stitching.